Hello everyone. In this video, I'm going to talk about the synthesis of Vilmoraconitine, a natural product that features a heptacyclic core. The synthesis begins with the addition of the aryl lithium species generated in situ from aryl bromide and N-butyl to the aldehyde. This produces a mixture of diastereomers in 91% yield. The alcohol is then treated with iodobenzene diacetate in methanol, leading to an oxidative dearomatization. This step provides the substrate required for the desired intramolecular Diels-Alder reaction, which occurs between the diene and the dienophile to give exclusively the endocycloduct. This product arises from the alkene approaching the diene with the substituent oriented towards the pi system. After separation of the desired isomer, methylation of the hydroxyl group is achieved using sodium hydride and methyl iodide. Next, desilylation occurs after exposing the substrate to TBAF. Subsequent oxidation with IVX provides the aldehyde, and treating the aldehyde with potassium terbutoxide generates an enolate intermediate, which is quenched with methyl iodide to produce the aldehyde in 89% yield as the only isomer. This occurs as the methyl iodide approaches the in situ generated enolate from the sterically less hindered phase, installing a quaternary stereogenic center. Reductive combination of the aldehyde with ethylamine hydrochloride and sodium cyanoborohydride yields the secondary amine, which is protected with a Boc group by adding sodium hydroxide and Boc anhydride directly to the reaction mixture. The product is obtained in 90% yield. After that, the ketone is further reduced to an alcohol with lithium aluminum hydride. Then, the acetal is removed under acidic conditions, and finally, reductive removal of the hydroxyl group with samarium iodide provides the ketone in 62% yield over 3 steps. The ketone is then subjected to these conditions to effect a hydrodealkenylative fragmentation. This generates the aldehyde in 77% yield. For more information about this interesting transformation, check out this paper. Addition of TFA to the substrate promotes the Boc cleavage and the Mannich cyclization to give the tetracycle. The Mannich reaction involves the condensation of an aldehyde or ketone with a primary or secondary amine and a non-enolizable aldehyde or ketone to prepare aminoalkylated derivatives. Treatment with LDA generates the enolate by deprotonating the alpha carbon of the ketone. The enolate is then quenched with methyl cyanoformate, also known as Mandel's reagent, to install the methoxycarbonyl group at the alpha position of the carbonyl group. The Robinson annulation takes place in 2 steps. First, a Michael addition with methylvinyl ketone and cesium carbonate, which attaches the methylvinyl ketone from the less hindered convex phase of the substrate, producing a single diastereomer. Next, intramolecular aldol addition of the diketone proceeds with potassium HMDS, generating an additional ring in 85% yield. The ketone of the pentacyclic product is then protected as the corresponding dimethyl acetal using a Lewis acid and methanol. This allows for the reduction of the ester to the aldehyde in 2 steps. First, reduction to the alcohol with lithium aluminum hydride, followed by oxidation. Although Diebel can reduce esters to aldehydes in a single step, the reduction is sometimes difficult to control. Therefore, it is often more convenient to reduce the ester fully to the alcohol and subsequently oxidize it to the aldehyde. The aldehyde undergoes Horner-Wadsworth-Emmons olefination with LDA and a phosphonate to give the corresponding E-alkene. The alkene is then treated with TMS triflate to provide the alpha-beta unsaturated ketone in 86% yield. By the way, if you're interested in name reactions, you will love the chemist's cookbook. It contains 201 name reactions with real examples from the total synthesis of natural products, along with experimental procedures. Check the description for more details. Since the tertiary amine within the enone interferes with subsequent steps, it is oxidized to the corresponding amide, and the lactam is obtained in very good yield using iodine and sodium bicarbonate. Do you know the mechanism for this transformation? Let me know in the comments. The enone gives rise to the enol silane with TMP and TBS triflate. Heating the reaction to 150C promotes the intramolecular Diels-Alder reaction to deliver the heptacyclic product upon acidic workup. Interestingly, the regioselectivity in this transformation is opposite to what would typically be expected. In Diels-Alder reactions, the regioselectivity usually follows the orthopara rule. The regioisomers obtained are predominantly the 1,2 and the 1,4 products, rather than the 1,3 products seen here. Reduction of the ketone with sodium borohydride gives the alcohol with excellent diastereoselectivity. Methylation of the secondary alcohol is accomplished using potassium terbutoxide and methyl iodide. The next step involves an oxidative decyanation of the secondary nitrile. This transformation is achieved using LDA and oxygen, followed by quenching with thin dichloride and workup with aqueous sodium carbonate. Finally, the lactam is converted back to the tertiary amine in two steps. First, reduction of the amide and the ketone groups with lithium aluminum hydride, followed by oxidation of the resulting secondary alcohol. Thank you for watching. I hope you enjoyed the video. Please subscribe, like, and leave me a comment down below. I'll see you in the next video. Bye!